So let's keep going with these trigonometric equations, okay? I want to solve sine of 2 theta is root 3 over 2. Theta is between 0 and 2 pi, but notice I'm not taking the sine of theta. I'm taking the sine of 2 theta, and this is really going to change what we have to do. Okay? So the sine function, forget the 2 theta, just consider sine of question mark equals root 3 over 2. Okay? It will have two solutions. Okay? Pi over 3 and 2 pi over 3 are two angles in one rotation of the circle where the y-coordinate, the sine, is root 3. Okay? So that tells me my question mark angle must be pi over 3 or 2 pi over 3 plus any integer multiple of 2 pi. I'm not worrying about the restriction yet. We're going to get there. Okay? So the thing I'm taking the sine of must be pi over 3 or 2 pi over 3 up to adding one full rotation of the circle. And I'm not taking the sine of theta, I'm taking the sine of 2 theta. So from here we get, I'll get to this picture later. Let me actually clear out my work. Okay, so we've just determined, so off on the left, I'm just going to repeat the work that we had. So the sine of something unknown is root 3 over 2. Forget any restrictions, okay? This tells me this unknown quantity must be pi over 3 plus a multiple of 2 pi or 2 pi over 3 plus a multiple of 2 pi. But now I say, what am I taking the sine of in this question? We're going to go over to the right now. That 2 theta is the thing I'm taking the sine of. So that must be pi over 3 plus 2 pi times an integer, or 2 pi over 3 plus 2 pi times an integer. And now I can divide by 2 and get theta is equal to pi over 6 plus an integer times pi, I've canceled off the 2, or pi over 3 plus an integer times pi. And now I can start paying attention to the restriction. So I'm going to erase my work off to the left and finish up the way I would generally do this. So by ignoring all restrictions on the angle, we have found that the thing I take the sine of is pi over 3 or 2 pi over 3 plus 2 pi times an integer. Setting the thing I'm taking the sine of to be 2 theta and then dividing by 2 gives us my angle must be pi over 6 or pi over 3 plus an integer times pi. And now let's take a look at the restriction. How can pi over 6 plus an integer times pi be in between 2 pi and 0? I can either have k equals 0, in other words, my angle is pi over 6. I can have k equals 1. That gives me 7 pi over 6. But if I did k equals 2, notice I would have 2 pi plus something. That's too big. And if k is negative 1, overall the angle will be negative, and that's too small. Okay, so I have found two possible solutions corresponding to the general solution of pi over 3 plus 2 pi an integer. So pi over 6 and 7 pi over 6 are two possible solutions, but it's not it. Okay, so I'm going to erase the work on the right now, because we haven't addressed this possibility that theta could be pi over 3 plus k times an integer. So now the question becomes, for which choices of k will this be allowable? Now, for which choices of k will 0 be in between pi over 3 plus an integer times pi? Well, again, if k is negative 1, overall that's negative. Pi over 3 minus pi is negative. If k is 0, I get pi over 3, and that works. If k is 1, I get 4 pi over 3, and that's still less than 2 pi. But if k is 2, I get 2 pi plus something, and that's too big. So we get these two solutions here. So the way we did this is we said, forget the restrictions, ask, and forget the fact that this is 2 theta. Just call it, unknown angle. And we'd say the unknown angle has this general form of pi over 3 or 2 pi over 3 plus 2 pi times an integer. Then we said, instead of calling it question mark, call it 2 theta and divide by 2. And that got us theta was pi over 6 plus an integer, we canceled off the 2, or pi over 3 plus an integer. And now I bring the restriction back in. If this is the angle theta, what choices of k will satisfy the original restriction between 0 and 2 pi? and we found 4 solutions, pi over 6 and 7 pi over 6, and pi over 3 and 4 pi over 3. Okay, so let's see an alternate solution. This is how the book is going to do it. If you plot the curve sine of 2 theta and compare it to the height root 3 over 2, since the period of this is just pi, between 0 and 2 pi, it's going to do 2 complete cycles, which means it's going to hit this line 4 times. So we know we're looking for 4 solutions. Okay. So how do we find those 4 solutions? Again, our general solution was pi over 3 or 2 pi over 3 plus 2 pi times an integer. We cancel off the 2, and then we ask which ones solve our restriction. -1 fails in both, 0 works in both, 1 works in both, 2 fails in both, and overall we got the 4 solutions. Okay, let's try. Sorry, this is now just stating, yes, we found the solutions. Here are the intersection points. Yeah, it's nothing, no new information. Once we had found these 4 solutions, the problem was done. It just said solve it. Okay, how about this? The tangent of theta minus pi over 3 is root 3, and theta is in between 0 and 2 pi. Okay, so pause, try to work it out. You can either do it the way I like to do it, where I say make the argument an unknown angle and then get back to it later, or you can do this more graphical approach that the book does. Either way, try to find all possible solutions. I'll give you a hint. There are 2 of them. All right, let's check if you got the right 2 answers. So the period of the tangent function is pi, and we know on one period it's 1 to 1, so that's how I knew there were going to be 2 solutions. On one period, it can only achieve a given value once, and I have 2 full periods of it, so I'm going to achieve every value twice. Now, we do know a specific angle for which we get out a tangent of root 3. That would be the tangent of pi over 3 is root 3. However, we are not taking the tangent of theta, we're taking the tangent of theta minus pi over root 3. So theta minus pi over 3 is the thing I'm taking a tangent of, so it must be the angles whose tangent is what I want. Remember, we recognize that the tangent of pi over 3 is root 3. Since a tangent has a period of pi, we can add any integer to it, and now this is the angle we're taking the tangent of. So the angle we're taking the tangent of could be our one solution or shifted by any period. And now we can bring the restriction back into it. Okay, we want this result of theta to be in between 0 and 2 pi. So the first thing we're going to need to do is move that pi over 3 over. So if I add pi over 3 to both sides, we can, whoops, I'm in eraser mode. If I add pi over 3 to both sides, that will cancel, and this will become 2 pi over 3. So that's where that's coming from. And now I ask which values of k will be in between 0 and 2 pi. K equals 0 and k equals 1 will do it. So there are 2 solutions. They are 2 pi over 3 and 5 pi over 3. Okay, let's do another. Find all angles in between 0 and 2 pi for which the tangent is -2. Okay, we're going to need to use a calculator. Pardon me. So the first thing we might do is take the arctangent and say theta is the arctangent of 2 and get -1.1. And a lot of students, if this were an exam problem, would stop here. They would just write on the exam, tan theta equals -2, theta equals arctan of -2 equals, and we use a calculator, so indicate that, equals -1.11, round it to 2 decimal points, and they'll stop and they'll be like, yay, I just did this problem in 5 seconds, I'm the best. Unfortunately, they only got half the problem correct. Okay. And in fact, maybe even less than half, because this gives me an angle of -1.1 radians. It's not even in the interval from 0 to 2 pi. Now here's what happened. Arctangent produces an angle in quadrant 4 or quadrant 1. We just got an angle in quadrant 4. Okay, we don't want an angle in quadrant 4. We want an angle in either quadrant 1 or quadrant 2. Or quadrant 3 or quadrant 4, but not negative. Okay, we want to go up to 2 pi. So -1.1 is too small, it's less than 0. Okay. So this negative 1.1 can't possibly be one of our solutions because it's negative and we weren't looking for negative angles. But we know, they didn't write it quite the same way they did in the earlier ones. We got arctangent of 2 is about negative 1.11. Okay. But the tangent period is periodic with period pi. So our theta is going to be negative 1.11 plus any multiple of pi. And then our restriction was we want theta to be in between 0 and 2 pi. So k equals 0 does not work here. However, k equals 1 gives me pi minus 1.11. That's positive. And 2 pi minus 1 is positive, and it's definitely less than 2 pi. But 3 pi minus 1.11 is too big. So that's not a solution anymore. So we found two solutions corresponding to the fact that from 0 to 2 pi we have two full periods of the tangent function. We were expecting two solutions. And there they were. Okay. About 2.03, pi minus 1.11, and 2 pi minus that, which is 5.17. Now, I've remarked before, you never need a calculator, right? So here's how you would do this problem without using a calculator at all. Okay, so just right here is the original formulation of the problem. Okay, so we'd say theta should be the arctangent of negative 2. Now, based on our knowledge of how tangent works, we know that arctangent is restricting the domain from minus pi over 2 to pi over 2. I wanted to get out a value of negative 2, so something down here. So what we conclude is arctangent of negative 2 is in between, is less than 0. Sorry, let me rewrite that so that I have enough space to write it. So just by knowing how the tangent function works and the fact that arctangent is going to use the domain between negative pi over 2 and pi over 2, we conclude that negative pi over 2 is less than the arctangent of minus 2, which is less than 0. In other words, I'm somewhere in between 0 and minus pi over 2. That's where this angle is. Somewhere to the left of 0, but not all the way to minus pi over 2. So now I know that my restriction is I want the answer to be between 0 and 2 pi. So let's add pi. So now let's do pi plus the arctangent of negative 2. That's less than pi, and it's bigger than pi over 2. Pi plus negative pi over 2 is going to be positive pi over 2. We're looking for things in between 0 and 2 pi, and we just found something in between pi over 2 and pi. So this works. So pi plus the arctangent of negative 2 is one legitimate solution. Now let's try adding pi again. Because the tangent function has a period of pi, I can just keep doing that. We'll get 3 pi over 2 is less than 2 pi plus the arctangent of negative 2 is less than 2 pi. That's adding pi again. And hey, that's less than 2 pi and definitely bigger than 0. So that also works. Let's try it again. Well, if I add pi, I'm going to get 5 pi over 2 is less than 3 pi plus the arctangent of negative 2 is less than 3 pi. And now this is too big. So I'm done. Here are my two solutions, and we didn't use a calculator at all. It's the same two solutions. It's just using the fact that the arctangent of negative 2 is negative 1.1 something. So it's the same answers. But you really don't need to use a calculator to do this, and it didn't even really help us. Okay? If you know how arctangent behaves, you recognize that arctangent of negative 2 is going to be a negative angle somewhere between minus pi over 2 and 0, and then you have a problem with no calculator at all. Okay, how about another example? Sorry, this is the same example, just done another way. So this is recognizing, yeah, that this angle here, negative 1.11, arctangent of minus 2, is the wrong direction. But if I just add 2 pi to it, I will be the same thing, but now positive, but still less than 2 pi because we didn't go all the way around to the right. And this angle is just adding pi to it, and that's going to be in the standard one rotation of the circle. It's really the same argument. It's just with a picture. I'm not sure this really needed a whole new slide. Okay, so that's it for this video. What you can do now is solve anything of the form a times sine or cosine or tangent of b theta plus c plus d equals 0. I mean, anything like this you can solve. So let's just do one quick example where a calculator would be kind of helpful, but not necessarily. How about 2 times the sine of 3 theta minus pi plus 1 is equal to 0. And let's say that we want all angles theta between 0 and pi. Why not? Okay, so we're going to subtract 1 and divide by 2. That gives me the sine of 3 theta minus pi is equal to minus 1/2. Now in our standard unit circle, I want the sine, or the y-coordinate, to be minus 1/2. That gives me two angles here and here. Okay. This angle here is minus pi over 6, and this angle here is 7 pi over 6. So that tells me the thing I'm taking the sine of is either minus pi over 6 or 7 pi over 6 plus 2 pi times an integer. Okay, it's one or the other. It's either this solution over here or this solution over here. The standard angles to use would have been negative pi over 6 or positive 7 pi over 6, but then I can shift them by full periods. Okay, so then what we ask is, for which values of k is 0 going to be less than or equal to 3 theta, whoops, so then, sorry, what we should do is we should add the pi and then divide by 3. So if I add the pi, we end up with 3 theta is equal to, notice you can add the pi either to these terms or to these ones. I'm going to add it to these ones here because this just has a nice whole pi in it. So it's either negative pi over 6 plus 2k plus 1 times pi, or it's 7 pi over 6 plus 2k plus 1 times pi. Now I'm going to divide by 3. I need to delete some stuff so that I have space. Okay, there was our original problem. I've erased that. I'm keeping the restriction visible because that's going to be important in a bit. Okay, so the next step is to take these two equations and divide by 3 so that we can finally solve for theta, which is going to give us theta can be negative pi over 18 plus k plus 1 over 3 times pi, or it can be 7 pi over 18 plus 2k plus 1 over 3 times pi. And now the question is, how do I get out something between 0 and pi? So I'll label these option 1 and option 2. Okay? So for option 1, k equals 0 will be negative. So that's out. Okay, if k is, k equals 0 won't be negative, I take it back. So let's try it, okay? Let's try k equals 0. We end up with negative pi over 18 plus 1/3 pi, which is, so using 18ths as our common denominator, 1/3 is 6/18, so this is 5 pi over 18, which indeed is in between 0 and pi. That's a totally legit solution. Let's try k equals 1 in the same equation. Negative pi over 18 plus, now if I put k equals 1 up in the numerator, that numerator becomes 3. So I have 3 pi over 3, which is aka just negative pi over 18 plus pi. The common denominator is 18. This gives me 17 pi over 18, which is still fine. That's still less than pi. But it's pretty clear if I add more to this, I'm going to be too large. Just double check that. Okay. So if we add k equals 2, we end up with negative pi over 18, and now my numerator, 2k plus 1 over 3, is 5 pi over 3. Again, common denominator is 18. Multiply by 6, that gives me 30 over 18 in the second term, for a total of 29 pi over 18, which is too big. So k equals 0 worked, k equals 1 worked, k equals 2 is too big. Let's verify that k equals 1 is too small. That's going to give me negative pi over 18 Now, if I let k be -1, we end up with -2 plus 1, or -1/3 pi. So notice I have a negative and a negative. This is definitely less than 0. This is too small. So we have two solutions. Okay, 5 pi over 18, 17 pi over 18. And that was just from option 1. Now I'm going to erase that whole bottom half of the page, and we're going to see from option 2 which values of k will work. Okay, I'm doing this more complicated example because once you get the hang of it, this is the same fundamental steps as the previous one. It's a little more tedious, but I wouldn't say it's fundamentally more difficult. It's the same steps, it's just more of them. And this is sort of like what you can expect on the midterm or the final, where it's a little bit more intricate than those first examples. It's not anything different, it's just slightly harder. So once you get the hang of the simple ones, things like this become, you might sigh and be like, oh, well, this is going to take a while, but it's the same steps in more or less the same order. So you just hack through it. So now let's use option 2. Okay. Let's try k equals 0. That gives me 7 pi over 18 plus 1/3 pi. Common denominator still 18, gives me 13 pi over 18. That's a perfectly legit solution. Okay, so I'll come up here and I'll write it down. Let's put it here. 13 pi over 18 worked. If I let k equal 1, we get 7 pi over 18, and now that second part, the 2k plus 1, gives me a plus 3 pi over 3, aka plus pi, or 18 pi over 18, which gives me a 25 pi over 18. This is too big. So k equals 0 worked, k equals 1 didn't, but let's try the other direction. What about k equals -1? Then we get 7 pi over 18. If k is -1, then we get a minus pi over 3. Common denominator is 18. This is going to give me a pi over 18, which works. That is positive and less than pi. And if k is -2, we end up with 7 pi over 18 minus pi over, minus 3 pi over 3. So 7 pi over 18 minus pi gives me -11 pi over 18. Since that's negative, it's too small. So for option 1, we had 2 solutions. For option 2, we had 2 solutions. So overall, there are 4 solutions to that problem. So as I said, this one took a little bit work, but it was not different work. It was just more of it. So don't be intimidated if there's more steps to a problem. They're going to be the same steps you've done before. Anyway, in the next video, we'll come back and we'll keep working with things. But notice now we have a sine squared. So this is what's called a quadratic form.